All right, guys, we will start with the session. All right, so I welcome you to Skill Vertex. So about Skill Vertex, what can I talk? So Skill Vertex is a growing edtech platform. We have started some 2 years back, and we have, we focus on attention to upskill you guys, where we provide a plethora of programs. All right. So Skill Vertex emphasizes on the needs and future aspirations of individual, connecting to emerging industrial technologies and requirements. We are a place where students entrust us with personalized mentoring directly by industry professionals who mold students and assist them with career development and also incubated development. All right. So when it comes to your career, no question should be left unanswered, right? And hence presenting to you a webinar, a series of webinar which we do. It's called a Skill Connect. Now, this webinar is actually very special because it's a IIT Roorkee certification specialized webinar with, data science. Okay. So yeah, let's proceed. Am I not audible to you all? I just saw a text. I am right. Okay. So sorry, guys. Okay, fine. So let's go ahead and I present to you Skill Connect basically. So we have recently launched a new program, which is IIT Data Scientist Program certified from IIT Roorkee. All right. So this webinar is all about that, as well as we have a very interesting topic about machine learning. As you guys know, after Open AI, you can see a lot of machine learning and AI stuff, flooding over the internet, and a lot of people getting so much interested into machine learning, and hence, to hop on the trend and to actually upskill you guys, we have announced this particular program. And moreover, more special is this webinar where we are going to teach you about overfitting and underfitting in machine learning. It is specially been taken by Akash Maurya. So what to talk about Akash Maurya? He's a data scientist and he is working in Deloitte itself. So he has a very good experience in terms of data science and machine learning. He's also a mentor at our platform for data science and machine learning. So over to you, Akash, and you will be learning more about regression models and more about overfitting and underfitting in this particular webinar. So focus on giving attention to what Akash says, because it is really important for you guys and your career as well. So yeah, over to you, Akash. Hello.
Hey, thank you. I hope I'm audible.
Yeah, you are.
Hi. Hi, Shravani. Thanks. That was a great introduction. And I hope, like you just told my words that I wanted to say to the people. So this is a really, interesting topic that we have chosen today as a series of our Skill Connect. In this particular session, we are going to talk about, machine learning. It's particularly, linear regression models, and with respect to that, we are going to understand the overfitting and underfitting into machine learning. How to avoid that? Why do we, why does it happens? The cause and the solutions to that, and what else we can do to solve that as well. So that's what we are going to look into today. I hope this session brings basic understanding of the topic, and also as well as the basic of what we are going to go ahead in further, as Shravani already told us about the session that we are going to have, the certification program that we are going to have. So that will be these topics like this, and the previous webinar that we have, and the one that we will do in future as well. Everything will be discussed in a very, I would say, explanatory manner. And with that note, let's just start this. Let me just start sharing my screen. Let me know if you guys can see that. One sec. Can you see the screen? Yeah, I hope you can. Let me know if you can see the screen, guys.
Yes, yes. All of us can see the screen, Akash.
All right, that's great. So let's just start this. So as I said, we are going to talk about the overfitting and underfitting in machine learning. And in this particular session, we are going to deep dive into the world of regression models, particularly linear and polynomial regression. And with the help of that, we are going to understand this, overfitting and underfitting. All right. So in order to go to that machine learning, to the regression model first, let me just make you understand what exactly is machine learning. So, you can simply go, I'm not going to go through the PPT, read out through the PPT to you guys. You can simply go this, you can also get this PPT as well later on. The thing is, what is machine learning? I'm not going to read out the PPTs as I said. So machine learning is, I would say there is a black box analogy. So machine learning, think about machine learning as a black box. And when you think about as a black box, so it has, certain rules to find out a relationship between the input and the output that you have given, right? So for example, let's say we do not do the things which are rule based with the help of machine learning, right? For example, if I ask you to add two numbers, 1 plus 3, so we don't need to actually do that with the help of machine learning. Even if we do that, we'll not get the accurate answer. We use machine learning where the rules are not exactly defined, right? But we do it eventually every day. For example, if I ask you about driving a car, cooking the food, I mean, everybody can tell you that how much, ingredient you should, but if me and any five-star chef has to cook something, then definitely, I would say I will cook better. That's a joke, that. So basically, the person who has a lot of experience, they will be actually doing that in a much better way because they have learned it over times. They know, not only the time, even if you just fix the time when you have to put what ingredient and what time, what amount, even then, any machine cannot cook better than the chef. So this is something called experience. So what we try to learn in this is with the help of actual data, we try to learn the relationship between the output and so the data, the ingredients that we have, and at the end, what exactly we are getting as the food. It tries to, find out the relationship between that, and that's why we say it black. Why we say it a black box? Because we cannot actually define that as well. What exactly is that? In some cases, let's say linear regression or polynomial regression will have a complex equations, sometimes linear equations and sometimes polynomial equations. But if you go further than that, let's say if you go classical machine learning or even if you go deep learning, these are nothing but just bunch of weights, and we have a neuron structures, neural networks actually. So that is that. So we use machine learning in things like that cannot be defined by a set of rules, like driving the car, like cooking the food, like recognizing apple and oranges, like a bunch of tasks that cannot be defined in a rule. All right, let's say if I ask you to define person to person, right? Everybody has nose, everybody has eyes, everybody has lips, teeth, and everything. But you cannot distinctly define the rule that Akash looks like this, Shravani looks like this, and some other people looks like that, right? So that is another thing to to discuss about. So, but machine learning can extract the feature between every individual's faces, and they can actually translate them, and they can distinct features, and you can actually understand that which face belong to which particular person, right? So that is machine learning, right? Again, you can just read out to this. There are three types of machine learning in this: supervised, unsupervised, and reinforcement learning. Supervising learning is something when we have a supervisor present in the data. Basically the supervisor is present in the form of data itself. We have we have I would say an output data, a label data we have, and that's what we call a supervisor, because that helps us to find out the error, and with the help of that error we try to actually minimize, or we try to make the model much better as we want, right? Because we using the error that we have. And okay, one more thing I would like to say before proceeding to this, I would say that if you have anything, any question to ask, you can simply write in the comment section, or you can, if you are able to unmute, then you can also unmute yourself as well, right? I will definitely answer your queries. Okay. Yeah. Moving forward. So supervised learning, as I said, there is supervisor present in the data in the form of labeled data. We can have, either regression model. I mean, either continuous numerical value for the regression, and either discrete classes for the classification, right? So and in unsupervised learning, we do not have that particular class label. And that is why we try to find out the hidden pattern in unlabeled data. That unlabeled data means there is no labeling in the data. That means there is actually, just the data that we have, and there is no class labeled or the numerical categories that I just discussed previously, right? And reinforcement learning, you can think about it, a guy, a student who does not learn, but you make him learn by rewarding him or punishing him. If he does bad things, then you punish him. If he does good things, then you reward him. And that's how he learns to do good things, because he wants the reward. Nobody wants the penalty, right? So that's how. And similarly, in the case, you can also understand, let's say there is a kid who wants to, walk. So you have just kept a chocolate for somewhere, and then in the greed of that chocolate, he walks to that. And if he is able to walk till there, he will get the chocolate. So that's a reward for him. If he falls down sometimes, he feel pain or something, so that is a penalty for him. So he will avoid doing the thing by doing what he just fell down and got the pain. So this is what, it's kind of reinforcing the learning agent to learn the behavior of the environment, and then understand how to learn the good things for which it can maximize its reward. So that's the reinforcement learning. All right. Moving forward, as I already talked about unsupervised and supervised learning and reinforcement learning, there is also some folks also talked about the semi-supervised learning as well, but I don't believe in that actually. Semi-supervised learning is nothing but just a combination of, supervised and unsupervised learning, where you just do a few things with the help of supervised learning and then do a few things with the help of unsupervised learning. You may also believe my analogy as well, or you can also, feel free to understand what you like as well, right? All right. As I've already talked about, within supervised learning, we have classification versus regression. So we have, in classification, we have distinct classes to categorize with. In regression, we have, linear data to fit the line. So let's say if I give an example of, classification, I would just ask you a question, right? So as I said, classification is nothing but when you try to predict distinct categories or distinct classes, right? So that is a classification. Again, for an example, cat or a dog, right? Or a bird, right? So there is nothing, I mean, if you have an image of a bird, cat, or a dog, they can be categorized into either, I mean, bird can be categorized as a dog as well. That's a misclassification. That's a wrong classification. But there is nothing other than these three if we have these three things in data, right? So, and on the other hand, the regression model, we try to predict the continuous numerical value, right? As you can see here, we are trying to create a line on a data that we have, right? So, for this, let's say, if I'm asking machine learning model to predict the, I would say the salary of someone, right? The salary of someone can be literally anything in a given range. I cannot define the range. Companies are, data scientists are being paid a huge amount of salary. So I just cannot give a range of 1 crore or 2 crore. But, starting from 0 to a particular value, 1 crore, 2 crore, whatever is the upper limit you think, the salary can be literally anything. It could be 33,561 values, 95 rupees as well, right? And it could be literally anything. But when I talk about classification, in classification, we just have the distinct classes, right? So that is the difference between regression and classification, right? Now, if I ask you, let's say, you can just write down your answer in the comment. So if let's say I'm going to predict the grade of students, right? If I'm going to predict the grade of students in the range of like from 0 to 100, right? So I'm not sorry. The grade of students should be either classified into A, B, C, and D, and C, D, and F, where F is failed, A is the most, the best grade that one can get, and then B, and then C, and then D, E, and F. F means fail. So what kind of a problem is it? Is it a classification or a regression problem? Love to hear your answer in the chat. People have answered multi-class classification. That's correct. Yeah, so yeah, that's Katir classification. Everybody is saying classification. It's just, that's the correct answer. I hope I'm able enough to make you understand that. Instead of, let's say, now the next question comes up, instead of predicting the grade, if I'm predicting the marks, I will say percentage mark obtained by a student, and percentage mark, that ranges from 0 to 100. So what kind of a problem that will be? Regression. I think Katir Pandian was waiting for me to finish the question, and he was ready with this regression answer in the chat. That's great. So that's a very good analogy. That's how you can understand. If you have a continuous numerical variable, then that's a regression. If you have a classes, distinct classes, then that's called the classification. That's great. You guys are responding really, really well. Now, let's move to the next thing, which is linear and polynomial regression. See, you might have understood the the equation of a line, right? So equation of a line is nothing but 1 degree model, 1 degree polynomial, right? A linear model, linear I would say linear equation, right? So it's like y is equals to mx plus c, right? But when I talk about polynomial regression, I think there is some mistake in the equation. As you can see, x is square bx plus c, it should be. That's my bad, I guess. Yes, somebody has a question. Shravani, can you unmute himself, or you can also type a question in the chat. Sheikh Kareem, do you have any question, or you just rose your hand accidentally? I think that was accidental. No problem. Yeah, so when you have when you're going to going to create a line. Let's say you have a data again. Let's say I have a salary data, right, of people. Let's say I have experience and the salary. Let me just show you a different screen, then you'll be maybe able to understand that better. So let's say we have a certain x and y axes. I hope you guys can see my OneNote screen. Shravani, am I right? Yeah, okay. Right. So let's say in this axis we have experience, the year of experience, and in this axis we have the salary, right? So like random data we may have, but everybody knows that as the experience increases, the salary will also increase. So let's say we have this kind of a data. Now, if I'm going to fit this data, the best thing to fit this data is with the line, right? I'll just create a line, and this line fits the data. Fitting means the line that passes through most of the data points, or not passes through, then it passes close to those data points. If I am going to create, let's say, a parabola on this like this, that's not a good curve to fit, right? And the equation of a line is nothing but y is equals to mx plus c, and which is nothing but a linear equation. And that's why we call it linear regression, because we are going to fit a line on this, right? On top of that, let's say if we have something else, let's say we have something, this kind of data, right? I'm not exactly sure what input and output should be. Let's consider, two x1 and x2 like that. Let's say here we have x1, here we have x2. Somebody has a, yeah. So let's say if I am going to fit this data with a line, right? Somebody may say that, yeah, this is a good fit. I mean, we are able to go through, if not close to our point, then maybe close to them. But in compared to this, if I, let's say, create a line like this, or a curve like this, so this is, the curve fits this data better than this line, right? So this line is not able to find the pattern or twist and turn in the data, right? But the curve is able to do that. And this is only possible if we have a polynomial equation. You cannot create a curve with a 1 degree model, 1 degree polynomial, right? It should be, if you know a little bit of maths or algebra, you might be knowing the critical point. If there are two critical points, then this curve needs to be at least a 3 degree polynomial. So it will be y hat is equals to ax cube plus bx square plus cx plus t, right? So this should be the equation in this case, with at least 1 degree of the polynomial. 2 degree of the polynomial. It may have the moving forward here, it may go and, turn around as well, maybe later on. But, at least I'm saying that it should be a 3-degree polynomial, right? All right. Now moving forward to the next thing, which is, so this is the difference between linear regression and polynomial regression. In linear regression, we try to fit a line. In polynomial regression, we try to fit a curve. Why do we try to fit a curve? Because the line is not able to understand the trend or twist and turn in the data, right? And that's why we try to fit a curve on that. Now, again, here comes understanding the topic that we are here for, which is nothing but the overfitting and underfitting. Underfitting means what? Underfitting means something we are not able to learn, right? If the model is not able to learn the complex data, that is called underfitting, right? So in this case, if you see this line here is underfitted because it is not able to, cope up with the complexity of the data set that it has, right? Now, this is called overfitting. I mean, line is overfitting. Line is overfitting, but this curve is perfectly fitted. On the other hand, let's say we have this, on the other hand, I would say we have this data. Now, let's say this is a linear model. Now, if I, let's say, create a model that mostly goes through, all these data points, right? So you might say it may have a little error, a smaller error, but, this will eventually give a wrong predictions in this case. So this will be a, overfitted model in this case. So the data is simple. It's just a line, right? It's just a linear trend. But what we are trying to fit is a very, very complex polynomial equation. That is not a good way to do that. And that is why it's called it overfitting. Overfitting means it's like you are doing the, the work of a very small knife. You are doing the work of very small knife with a sword, right? And in that's called overfitting. And underfitting is nothing but you are doing the work of a sword with a knife that you cannot do eventually. You are going to to fight the battle with a knife. That's not the way to do that. That's underfitting. And when you have to cook food, you are cutting the vegetable with the sword. Again, that's not a good way. So these are the very examples of underfitting and overfitting, right? So when your data set is very, very complex and your model is very, very simple, that is called underfitting. And when your data set is simple and your model is complex, then that is called underfitting. And we have to be, in between these two things, that is called perfectly fitted model, right? So we have to find out the perfectly fitted model. So let me just go back to the to our again this. So again, the same thing you explained here in this PPT as well. I'm not a very big fan of presenting PPTs, but still, this is the definition of overfitting that I just explained you, right? Overfitting occurs when a model learns the training data too closely, right? Including the noise and the outliers that we have, that leads us to the loss, right? See, here in this case, we had a simple sine function to cope up. But again, here we have, this twist and turns in the data that you see. That's not a good way to do that. That is something called overfitted model. And you can also see, right, data models, ideal data points, ideal models, and the perfect, the overfitted model that we have, right? So these are, instead of capturing the true underlying pattern or the relationship in the data, it is trying to focus on the, random noise or the random fluctuation or, the outliers and everything in there that leads us to higher, testing loss. Maybe the training loss might be a little bit, smaller than the perfectly fitted models, but the testing loss will be higher. Okay. There's one question, I guess, in the chat. Let me take that. So is linear regression is the best when analyzing the data, like increasing in interest of people to buy a particular product in every month or in a year? See, I would not say that, because for that I need to see the data first. And if the data supports that, then we can say that. Otherwise, it could be a regression model, but not sure the linear regression or something else, right? Not sure the linear regression or something else. Okay. So yeah, let's move to the next thing now. So this is the definition of overfitting. How, I mean, what exactly is overfitting and what causes the overfitting? Let's understand what causes the overfitting. Now, the complex model, complex model for simple problems, as I just told you about, right? Why does overfitting happens if we have a very, very complex model for a simple problem or a simple data? So that causes the overfitting in our model, right? Uh, for example, if we have a in this case, in this case of polynomial regression, if we have a higher degree polynomial, right? Higher degree polynomial in the sense, if we have a polynomial equation which is having the maximum power of x to be very, very high, so that becomes a higher degree polynomial, I would say complex model, right? Or else relying too heavily on the training data. Let's say the data that we have, I mean, eventually we all train on the training data itself. But if the training data that we have is is too specific, is not generalized, so that will occur under this overfitting cases, right? Again, one more thing, insufficient data or the data with high noise, that will also come with the overfitted model, because model will try to cover that noise as well, and in order to capturing that noise, it will be overfitted on the actual data. Instead of generalizing, it will be specifying the model, right? So that is again another reason for I would say overfitting. And insufficient data is always, if you, I would say, in machine learning, no data is ever enough. So if you have huge amount of data, that is the best way to do, create the machine learning model. So the the more data you have, the better the model you'll have. And not only the more data, but also the variety of the data should also be much, much higher. It's not should be like only one category of data is very, very high. That's called imbalance in the data, and that can also cause these kind of problems like overfitting or underfitting model, right? For example, let's say here I have explained the overfitting in the curve in the graph that you see, overfitted decision boundary. So that is another case of overfitted model, but in case of classification. But the one that I just told you before, that was in case of regression, right? This is in case of classification. Now you can see there should be a clear decision boundary. Okay, there should be a clear decision boundary. I'll show you how decision boundary should be. The decision boundary could be like this, right? But instead of being that, it has been, just like this random, this blah, blah, blah. That's not a good, actually, that's I would say a very complex decision boundary. Instead of being simple, it is being so much complex. And that is why that is an overfitted case. Again, once again, I'll tell you, if you have any question, you can simply ask the question in the chat. I will, do my best to answer that question. All right, let's move ahead now. One second. Okay. Now, what will be the impact of when we have an overfitted model? So, so the model will not be generalized, as I told you already. Let's say instead of picking the general trend, if the model is, specifically picking the, I would say, the noise in the data, or, different, I would say, a little fluctuation in the data. So that is also, bad thing. So what will happen? The generalization will not happen in your model. And that is a very, very big impact in here. So when this happens, the other thing leads to that, the higher testing error. When you are trying to test your model, and if you get higher testing error, so that is a big reason, because your model is overfitted. To recognize whether your model is overfitted or underfitted, you can simply see the training error and testing error. If the training error are significantly smaller, right, than the testing error, then significantly means there should be significant gap between them. So that we call it an overfitted model. Okay. Again, misleading the high performance on the training data. That's again, that's the thing I just told you. When you get a very, very low error in the training data, so that may be a case of overfitted model. Right. Sometimes we should stop reducing the error, because that's our generalized model. Otherwise, if you try to reduce the error, definitely our model is going to be overfitted. If you see, there is a graph here that tells us about the error and the epoch of the training. I'll tell you what is epoch. Most of you might not know. Epoch is nothing but when we train machine learning models, we just do not train it one go. We pass the data, right? We calculate the, error. We try to apply the optimization algorithm, maybe let's say gradient or something else. And when we have, applied the gradient, then we'll update the weight and then we'll do the same. Again, we'll do the prediction. Again, we'll, pass the data, do the predictions and calculate the error and then calculate the derivative and then update the weights and so on and so forth. This will do multiple times, and that one, circle is called one epoch, right? And that one epoch here, as you can see, at a certain epoch, not exactly 10. This is just a illustration, not exactly 10. Based on your problem, it might be differing as well. But after a certain amount of time, you will see that the testing error goes, wild. It keeps increasing, but the training error keeps decreasing, right? So that means this is where your model started, overfitting, and this is where you can stop and understand that. This is the most generalized model that you have. So in this case, the epoch 10, this is where we should stop training on machine learning models. So think about it, a kid, in your real life environment, let's say there is a kid. That's why, we say that we should not put a lot much pressure on the students, because in that case, they will not learn, they will memorize. And there is a difference between memorization and learning. When somebody learns, they understand the underlying thing behind that. When somebody memorizes, they just remember, they just murmur it and memorize it in their memory. They will not be able to understand the topic. For example, there is a teacher, right? There is a teacher who is teaching to students to how to add numbers, how to add two numbers. Let's say he has given a lot of examples in the class, right? Let's say 3 plus 5, 8 plus 9, 1 plus 3 and all that. Now, at the end, let's say if he's taking the exam, so if he asks the same question that he has given in the classroom, there is very, very high chance that there are some students who are going to, just memorize the questions and just put the answer. Even they do not know, they might not know how to add two numbers, but they have memorized it. So in that case, the teacher should not put those questions which were taught in the, which were taught in the classroom. They should not ask the same question in the, I would say, in the exam, in the final exam. That will help them to, understand, that will help the teacher understand who is exactly learning the thing and who is not learning, who is memorizing the thing, right? So that's the another way. Again, so that's called, overfitting, the impact and all that. Again, the underfitting, coming back to the underfitting, and I've already explained about that underfitting as well. So underfitting, drives us, arises when the model is too simplistic, too simple. As you can see in this, we have a data for, I would say a quadratic equation, but we are fitting a line. And in this case, we'll have a huge amount of error. And this is called underfitting. So underfitting is like there is a kid who is not able to learn the things that you are making him learn, right? The kid is very small, but you are trying to make him learn a very complex topic. So that's why he's not able to learn. That's called underfitting, right? Overfitting means you are giving a, a job, like you are giving a sweeper job to a PhD holder who is going to, do very, very research before cleaning that house. So that's not going to possible that. So that's, I'm just trying to make, understand all this with different real life examples so that you can understand, right? So that's called underfitted. Underfitted model means you have a very, very low capability model, but the data set is very, very complex in that, right? Again, what causes the underfitting? First reason is that the, simple model for a complex task. That's the thing I just talked about. And overlooking important features. That's the second thing. So when I say that, simple model for a complex task means ignoring or excluding the critical feature from the data that we have. Features means nothing but that part of the data itself. The columns are called features in the data. So when we exclude a particular feature or a particular column, which is very, very important for that particular task, right? So that can cause underfitting in the model. That means we do not have that factor which is closely related with the output that we want to predict. right? So that can cause the, again, underfitting in our model. Now, over regularization. So actually, regularization is a technique to avoid overfitting. But when we do it overly, I mean a lot, then that is called, that can also cause the underfitting itself. See what happens when we have an overfitting, right? We try to reduce overfitting by little bit, downsizing or the complexity of model. But if we have done it a lot, then the complexity of our model will be reduced a lot, and it will be much, much simpler than the model that we have. And that is another reason that, this underfitting happens. Underfitting also happens while coping up with the overfitting as well. That's an irony. So we have to, every time when we are doing all this, we have to be very, very cautious, and we have to monitor our model throughout the training, and we have to understand what exactly is happening in this, right? All right. Again, impact. What is the impact? Again, I have already talked about that as well. Like subpar performance, the performance will not be much better as you might have expected, because in this case it should be a sine curve or a curve like this, but there is a straight line. So again, there is going to be a lot more error in this case, or failure to capture the key pattern. Again, this is an example of not capturing the pattern of this, instead of making a line like that. Right now, how can we diagnose whether we are actually doing the overfitting or underfitting? So remember, I just told you about the teacher telling the students, how to add two numbers and all. So that is basically, I told you the conclusion that the teacher should not give the question in the exam, which he's teaching in the, classroom, because there might be some student who has just memorized those questions and has just, copy pasted it in the exam, right? So what will happen in that case? If you do not do, so those student will fail. Now you'll know that that student is not capable, and you can make him learn again, right? So there is that. But if you do that, so those students will also pass, and eventually they are going to, struggle in upcoming classes. So that's why we do test and split. This is called test and split. The data that I'm training with, I will not test with the same data, right? The exam, I mean, the question that I'm teaching them in the classroom, that I'm not giving to them in the exam. So the data that I'm training with, I will not use the data for testing. That's the one technique to diagnose. And in that case, if the training error is higher, right? If the training error is higher and the testing error is also higher, then that is underfitted model, means the model is not able to understand that. But if the training error is very, very small and the testing error is higher, then that is overfitted, because it has, just memorized everything. All right. Means there is a kid who is performing really, really well in the classroom, but but he's not able to perform in the main exam. There is a high probability that he's not learning it, but he's memorizing it. I mean, he's just, rattu tota kind of a thing, if you understand this Hindi word, right? So that's the thing. That's the overfitted model, I would say. All right. Learning curves. If you see the learning curve again, that's I talked about in the previous, here, right? This is also learning curve. When you see the error keep decreasing, but at a time you will see that error will start. I mean, the training error will start increasing. So that is, that is when it started happening, this overfitting, like coming back, right? So when we see this, so that will help us to understand that we have this overfitting. And the other way that I told you that, to understand, to see the training error and testing error, and to understand whether there is an overfitting or underfitting. There is also, a residual plot as well, actual value minus the predicted value. That tells us about whether the model is, that is basically used to determine or to get the underfitted model, actually, if there is a huge gap in there. Right. Now, solution to that. What is the solution to that? We can actually use the regularization. As I told you, one of the reasons for the underfitted model is that we do the over regularization, right? So the solution to overfitting is regularization, but we do it, a lot, then that becomes, I would say, underfitted model, right? So there are two types of regularization, actually, L1 and L2. So we actually penalize when it tries to, fluctuate a lot. We'll try to penalize the higher potential coefficient. So that is, I mean, It is trying to bring the complexity of the model down, right? So then it is nothing but, and you know why the overfitting happens? Because the model is too complex, and when we try to bring the complexity down, that becomes the solution for that. And there are two ways: lasso and ridge regression, right? Sorry, lasso and ridge regularization. Okay. In case of classification, in some other cases, pruning is another effective reason for an effective way to perform overfitting. Decision trees are very much prone to overfit, and that's why we use tree pruning in order to avoid overfitting. All right. And again, avoiding overfitting or solving any problem in machine learning just include more data. So if you have the data is more, if you have more data, if you have more diverse data for say, then your model will not be overfitted in that case. Maybe if you can apply all of these methods, then definitely you will have a very, very good model. Right. Now again, solution to underfitting: increase the complexity because the model is so less complex, right? You might have got that. And feature engineering, try to find out the best feature. Do not try to exclude them, right? Because that has the best collinearity with the output. So that is a very, very important feature. Do not miss the important feature. And reducing the regularization, the one again I talked about. Sometimes the underfitting also happens with the over regularization as well. So we can reduce the regularization to reduce the underfitting as well. There are few best practices that you can do is just check the model performance throughout the training. Try to plot the training and testing error and try to see what epoch value is the best to do that. I would say the training. So you can just stop at that particular epoch when you know that this is the perfect epoch to do it, right? And again, balancing bias and variance. Bias and variance, we can have another session for bias and variance itself. This is a very, very, great topic. So we have to, try to reduce the, I would say, bias and variance in the data, right? So, an underfitted model will have high bias, and overfitted model will have high variance. Variance means the fluctuation I talked about. If your model is fluctuating a lot, then it has a higher variance. And if your model is constantly missing the target, that is has high bias. Constantly missing the target means it is not able to predict the correct value, and that is underfitting, and that means high variance. And fluctuating a lot means high variance, and that happens in the case of overfitting. That's how we can correlate the things and understand in what case we have high bias and in what case we have high variance. Right. Again, question exceptional, training results. Right. For example, let's say you are creating a model, and in that you just got a really, really good training results. Right. Let's say 99.9% accurate results in the training, or a very, very good, very, very less error. Let's say 0.00009 error in case of regression problem. So when you have a very, very small error or a very, very high accuracy in the data, especially for the training data, if the data set is not so much easy, then again, that could be, that could be an overfitted model that you have to understand. So whenever you see an exceptional result, try to recheck whether that is an actual result or it's just one overfitted model, right? So that's again to find out how to, again, avoid this overfitting and underfitting. I hope that's these are the things that I just wanted to talk about. Again, if you want me to, just have a quick recap of that, then I can do. And if you have any question, then definitely I'm here to get your questions up.
Thank you so much, Akash. It was a really insightful session. So guys, go ahead and shoot your questions now. Akash is open for questions. So any queries you're having, even a simple doubt, you can ask him up and he can literally answer everything for you guys related to the topic. Meanwhile, guys, okay.
Please summarize the PDF in short. Yes, I'll do that. Just let me just pick up more questions if we have any. Then we'll summarize that.
All right, guys. Meanwhile, I'm just dropping a IIT course data science link with in the chat box. Please go through it and let me know if you have any doubts or queries.
And one more thing I just would like to add in here is that these are a very short session that we are having. Very, I would say important topics, but a very short time span that we have. But in case of when you have a full-fledged course with you, so that will give you a very broad perspective, not only this particular topic, but we'll start from the ground and then we'll build up at these understandings. So that will be, much better for you to understand these all. So just do check out that. Again, Shravani has given the link. Do check out that if you are really interested in learning these things.
Also, guys, there is a feedback form about the webinar as well. So please do leave us your
do rate my skills,
suggestions.
do rate my teaching skills. I would love to hear if I have any, any drawbacks, anything, then I definitely I will improve myself. All right. I don't have coding knowledge, but I am interested in data science. The mentor will teach from the basics. Yes, definitely from scratch. Professor doubt in epoch part. Please go ahead.
Guys, you can also raise your hand so that I can unmute you and you can directly communicate with Akash as well.
Yeah, if you are in a quiet environment, not in a very noisy environment.
Yeah.
I think if somebody has a very large question, they might be typing it by this time. And one more thing, I mean, do not wait for other people to ask the questions. I mean, just give your questions and I'll make sure that I will answer each and every question, no matter how many. Okay.
Akash, meanwhile, probably if we can share the course screen with them so they can see.
Right.
Yeah.
I think you can do that, Shani.
Yeah. That's what I said. I will be stopping there.
Yeah, okay. So I have a dog. I think Chat GPT is not part of this as of now, but yeah, definitely it's a very hot topic, we can go ahead in this runtime, no problem. Not a big deal. We'll actually not use Chat GPT, but we'll understand how to build Chat GPT for sure. But if you know how to build, then definitely you'll know how to use it. Koluru, you did not ask the question about your epoch part. Please, I mean, do not let me ask you guys to ask the questions. It's your job to ask the questions. All right. In ML include data science course, is ML includes? Yes, definitely. It's not data science without machine learning, which you explained earlier. See, Koluru, I'm not sure exactly what is your question. You said that you have some question in the epoch part, but what is the question that I'm looking for? Meanwhile, yeah. Okay.
Yeah. Am I audible, guys?
Yes, you are.
Okay, great. So this is the website, guys. You can see the page. I'll just try to, yeah. Yes. So this is all about our program which we have started. It will be starting from the 5th of the next month. So this is actually a certification from IIT Roorkee itself. And this is all about the course. You'd be getting a number of 40 classes, 40 live classes, which means live classes with the mentors. Along with that, you'd be getting 40 plus recorded classes as well. The live recordings will be uploaded on the LMS. You would be having a learning management system through which you will be, taking all the classes, as well as there would be a communication platform separately for you guys, which is nothing but Google Classroom, where you will be interacting with the mentor and all the fellow classmates which you have. These are the projects which are included in the course. There are 8 assignments for this particular program. We have customer segmentation, credit card fraud detection. These are the projects onto which you'll be working. Basically, these are capstone projects, which means they have specially been curated by the mentor for you guys, and at an industry level, so that you can actually understand and apply it very well. But before application, you need to learn certain tools, and these are the tools which we are going to cover. So it starts from the basic, which is nothing but SQL, Python, AWS, Power BI, Linux, GitHub, Jupyter Notebook, everything like Anaconda, VS, okay, VS Code, Visual Studio, Streamlit, NumPy, Pandas, yeah, Seaborn, Spicy, everything about it. And there are yes. So along with that, we have a mentor who would be guiding you step by step through this journey. It would be a 4 months duration. Okay. So yeah, that's all about the course. We would be also having placement assistance for the course. So we have collaborated with 70 plus companies out there, and also various corporates. So we'll be providing you training as well as placement opportunities. We would be also giving you free mock interviews along with the training part, as well as we would be giving you guaranteed interviews with companies as well. So yeah, that's all about the course. If you are looking forward to learn deep dive in data science and machine learning, you should definitely consider you know uh, going ahead with this particular program, because you will also be certified by IIT Roorkee at the end of the program. So yeah, that's all about the course. You can actually check out the website yourself and ask doubts right now if you have any, because we have dropped the link in the chat box. So you can also check out it yourself and ask any doubts if you have regarding the program as well. Also, yeah, that's about it, guys. Let me know if you have any questions regarding the same. Timings. So the timings would be flexible, Koluru. It would be mostly post 6 p.m. So all the mentors are also working professionals, right? So they also work somewhere at a firm, and we also know that you do also have college to attend in the daytime. So considering that, we have kept the timings post 6 p.m. only. So yeah, that's about the time range. It can be in between 6 to 7 or 7 to 8. It would be notified to you once you join the program. Okay, okay. If you are a working professional, then it's a feasible time for you as well. So also, if by chance anyone misses out, we would be providing recordings which would be available within the next 24 hours on the LMS portal. So you can actually access it from there. And if you have any doubts, you would be having a communication platform. You would be having live sessions. You would be having doubt sessions as well. Separate doubt sessions along with the mentor, where you can actually go ahead and ask your doubts apart from the daily lectures which would be happening. Okay. So yeah, there would be a specific timetable which will be provided to you all, and you'd be going ahead with the same. So yeah, that's all about, I guess it, I guess I answered your question, Koluru. Any other questions, guys? Anyone of you who is having any other question related to the topic or about the program or anything about? All right. Don't see any questions. So guys, please fill the feedback form. I'll again post it for you all. So this is the link for the feedback form. You can please fill the form. Thank you so much, Akash, for your insights about everything about underfitting and overfitting and also the regression models in detail. It really I was helpful for me personally because I don't actually come from a tech background, but yeah, I did understand a bit more of it. I hope the students must have seamlessly understood everything. Guys, you can give a thumbs up if you have understood everything. Yeah, we can see two others. Yeah. All right, guys, if you can come over the camera and we can just click a selfie, probably like yeah, Shubham. All right. Others, come on, Prathamesh, Anshul. Come on, guys. If you are in a comfortable seating, you can turn on your camera. We are just taking a screenshot, nothing else. Shubham is like, please accompany me. All right, guys. Okay. So I think we have to take, okay, Shubham also went. Okay. So we don't have very camera friendly people here. Okay. All right, guys. Thank you so much for joining. It was a great session, Akash. Thank you so much. See you all in the next webinar. Please stay updated. You will be getting notifications for the next webinar and everything about data science and machine learning. We are running this particular program in collaboration with IIT Roorkee. So please make sure you check it out. Please make sure you check out the page and everything about it. About more details, you can actually connect with our team and they'll be guiding you more onto it if you want to connect with them. So yeah, that's about it, guys. Thank you so much. I'll still click a screenshot. Akash, I guess it's you and me. Others, you have a minute, you can turn on. Okay, great. Okay, guys. So are we doing this victory sign or something? Yeah. Yeah. Okay. Thank you so much for joining, guys. Have a great day ahead.